Hello everyone, my name is Michael Olajide. I'll be discussing on the design and analysis of a hybrid power system for Port Hope Simpson, Labrador. Introduction. The progress of any community depends on the energy resources, which is a basic necessity in today's world. And also its availability directly affects both the existence of human and development of any culture. There are two factors that contribute to the rise in energy consumption, which are population growth and technological advancements. Generating clean and reliable and cost-effective energy is one of the critical challenges that is facing our present century, especially in rural areas. And according to the latest scientific research, fossil fuel account for roughly 78 to 80% of the global commercial. Most off-grid community in Newfoundland rely on diesel generator for their electricity and heating for their fuel. It will amaze us to know that 21 of the 27 communities are exclusively dependent on diesel generation, with an installed capacity of 31 megawatts. 15 out of these 27 off-grid communities are indigenous. And considering the connection between Newfoundland electricity generation mix and the rest of Canada, the province is an exciting area for research on off-grid energy sustainability. Literature review. In this work, we have tried to review several journals, several works that has been previous work that has been done on hybrid energy in rural areas across different countries. In one of the work, Lawan SM Elta studied, they reviewed different works on hybrid energy in different areas, and the resources that were used in those are wind energy and PV. And the software that was used, the method that was used is adaptive neurofuzzy interference system. Likewise, Yugan Wu Xin Shang also studied in Taiwan the hybrid energy in rural areas, and the resources that were harnessed in those areas were wind, PV, and diesel. Also, AS Aziz also studied hybrid energy in Iraq. Likewise, Jamil Oladigbolu et al. Studied hybrid power system in the remote community in Nigeria. And also we could see that I'm going through to the last one, which is MT Ikaba. Hybrid energy was also studied in Newfoundland, in rural areas in Newfoundland. So you see that we have in Francisco, McCollum, and and in Newfoundland. In those areas, hybrid energy has been discovered, has been studied. And we have decided to pick different literature from different countries. This shows to us that the issue of hybrid energy is being studied throughout different continents, throughout different countries. There's the issue of energy crisis. Objectives of the study. Number one is to design an optimal size standalone hybrid power system for Port Hope Simpson, using the existing load information to replace the current diesel generation system. Number two, to build and simulate a dynamic model in MATLAB Simulate based on the end result from OMA Pro to study the behavior of the system under varying environmental and load conditions. 3. To design a low-cost open-source SCADA system to monitor and measure relevant parameters in the hybrid power system and perform supervisory study area. Our study area is Port Hope Simpson, which is one of the remote communities in Newfoundland and Labrador, and they rely heavily on fossil fuel for their electricity generation. The location of Port Hope Simpson is on latitude 52.5433 degree north and longitude 56.3002 west. The population of Port Hope Simpson as of 2021 was 403, and there are currently 3 installed diesel generators in Port Hope Simpson with a total generation capacity of 2,000 325 kilowatts, which consume more than 836,760 liters of fuel annually, which is a lot. And this high cost of diesel is due to the frozen Labrador Sea during winter period, and this is a major challenge. And as a result of this, government have to continuously subsidize electricity up to 75% for the people of Port Hope Simpson. And the two graphics here, we have the pictorial view of Port Hope Simpson and also the chart for the population of Port Hope Simpson from 1986 to 20.
Hello everyone, my name is Obama Endurance Osas. I'll be standing on the existing protocol. I'm here to talk about the methodology of this project. This project was designed in the aid of some softwares. We used the MATLAB Simulink to simulate the dynamic response of the system, which will be shown in the course of this presentation. Also, we were provided with the opportunity to access the Renewable Energy Lab, where we were able to carry out our supervisory control and data acquisition system design. There we were able to monitor the data in our current system. And some components were put together to achieve the entire methodology of the project. The major component is the Arduino Uno R4 Wi-Fi. We also have 4 DC current sensors, and we also have a voltage sensor. All this put together, we're able to achieve the SCADA system design. This slide shows the solar wind energy training system, which can be found in the Renewable Energy Lab. This is our entire setup, comprises of the renewable energy systems existing in the lab. We have our workstation, we have our mobile phone, and also we have our breadboard where we did all the connections with all the various sensors, as well as our inverter, and then every other component to make up this system. And after the setup, we carry out an analysis, which will be later sent via the ThingSpeak portal. This slide shows our entire SCADA system that is designed for this project. As we can see, we will see 4 different DC current sensors. That is to help us sense the current from the wind turbine, the current from the solar system, the current from the battery, as well as the current from the inverter. Then we have a voltage sensor that helps sense the voltage for the battery. And also, proper view, you will see a breadboard. This was used to connect these various terminals together so that we can provide a common ground for the system, as well as have a common connection, just the way you have it in your bus bar connection or your junction buses, And also there we have our Arduino Wi-Fi Uno R4, which is used to interpret or extract all this information from these sensors. Okay, this slide shows the physical parameters. By this I meant the renewable energy system in our training lab, and we connected our sensors to the existing system. These sensors help us to pick information about the various voltages and currents from each of the components, both the solar system as well as the wind turbine. And this information were sent after the data has been acquired. They were sent to the Wi-Fi Arduino R4. The Arduino then picks up this data, and from the Arduino we wrote a code that will enable us to push this data from the Arduino to the ThingSpeak portal via internet connection. And from the ThingSpeak portal, we are able to get a visualized plot of our SCADA system that was designed. This we already achieved, and the project supervisor was able to see our real-time data as gotten or as derived from this ThingSpeak portal. This is our MATLAB simulation for the project. It shows how we connected the existing generator, the solar system, which is the PV photovoltaic module, as well as the wind turbine together. We connected them in different blocks and combined them together to get an overall output. And also in the course of this, we also added some capacitor to our what's it called, to our simulation. This is to also help to cancel ripples in the system, to help us get the type of wave we desire, because our aim is to check the dynamic system response of this design system. So we came up with these results after the successful simulation of the proposed hybrid energy system we have designed, which we previously used Oman to design. We simulated it, and the system outputs gave us these various information. We can see the state of charge of the battery, which shows a DC wave, which you can easily interpret from these results. And also we're able to get at the responses from the solar PV and responses from the wind turbine. So these waves were derived from our simulation. This is a typical representative of the dynamic response of the entire system that was designed using MATLAB software.
Hello students, this is Kato Yoon, and I'm going to talk about our experimental results which we obtained in the laboratory. As you can see, we worked on this panel. This is called Solar Wind Energy Training System Lab Board Series from Festo Company. We designed a system, a SCADA system, which with these parts as you can see in the picture. We used an Arduino Uno Wi-Fi as a communication device, and we did all those connections that were described before, and we obtained some results through the ThingSpeak. I use my mobile phone as a connecting tool, and I use the hotspot, and we transferred the results to the ThingSpeak website, and I'm going to show you the results that we obtained. Here in this slide, we have the results for our ThingSpeak website that we obtained. Here we have 4 charts, and we have ThingSpeak logged SCADA data plot results combined for both on-load and no-load conditions over the time shown in plots. So the time shown here is from 1310 to 1340, so it's like a 30-minute time span. And as you can see, we have 4 charts, and in these 4 charts, one of them is for battery current sensor, battery voltage sensor, and solar current sensor, and wind current sensor. Okay, let's start with the battery current sensor. So when in this system we are talking about the load, we are talking about 2 bulbs that we connect and disconnect, so we can have representative of load in our SCADA system that we used. And here we wanted to see how the system responds to the load and no load condition. That's why between 1310 and till 1325 we connected the load into our system, and that's why when we connected the load, the battery current sensor increased, and when we disconnected it, the battery current sensor decreased drastically. And as we can see in the battery voltage sensor, in the same time, when we connected the sensor, we had a very dramatic decrease in the battery voltage, and then we disconnected it, we had an increase, and then it got stabled. So moving on to the solar current sensor, the solar current sensor was never consistent because we had different radiations from the solar system. That's why we had we had so many fluctuations in our figure. And for the wind current sensor, when we connected the load, we had a dramatic change, an increase in the wind current sensor, and then when we disconnected the load, we had a very drastic decrease. So moving on to this slide, we have the ThingSpeak logged SCADA data plot results for no load conditions. So here we have the same results basically, but without the load. So we don't have any load, we don't have any lamps in this charts, and that's why we only have solar current sensor and wind current sensor, which we changed. And when we put the solar current sensor into our system, as well as the wind current sensor, we have battery current decrease, and we have a battery voltage increase in the same time, because we added the solar current and the wind current, like we just turned on the solar panel, and on top of that panel, and we just turned on the wind simulator that we had in the lab. And here in this slide, we have the same results, but this time for no load conditions. So here you see the ThingSpeak logged SCADA data plot results for load conditions. So here we have a load, which we don't disconnect. We never disconnect that. We just have it on from the beginning to the end, and we just change the solar current radiations as well as the wind current sensor. We turn on the wind simulator and the solar panels on top of our system. So here you can see when we turn on those solar and wind systems, we have an increase in battery current sensor and a decrease in battery voltage sensor, respectively. So as a result, the above data is the instantaneous data logged through the ThingSpeak server. The data is monitoring the current physical status of the system, obviously, and it proves that the system prototype can record the physical data and send to ThingSpeak to present the data graphically, which we did through a mobile phone hotspot and an Arduino Uno Wi-Fi. So the data collection time to ThingSpeak is 20 seconds. We couldn't use a shorter time or a longer time because it would be too short or too long. So we just figured it out through some trials and errors, and we realized that the perfect timing is 20 seconds. So this period ensures Arduino has enough time to gather and transfer the information to the internet, and it wouldn't be too slow either. So that's why we did. And in conclusion, the SCADA system designed for the hybrid power system in Port Hope Simpson, Newfoundland has been successfully developed and tested using a test matrix consisting of three main aspects. First step being the data acquisition, the second interfacing, and third is analysis and algorithm development. The electronic circuit was constructed with 3 current sensors, 1 voltage sensor for data acquisition, while the Arduino microcontroller was programmed to convert the electrical signal for interfacing. The virtual prototype of the SCADA system enabled designs to iterate to achieve the desired performance with checks performed for manufacturability, ease of assembly, tolerance, and interfaces. So overall, the successful development and testing of this SCADA system for hybrid power system in Port Hope Simpson, Newfoundland and Labrador demonstrates the potential of a SCADA system for enhancing the efficiency and reliability of power systems. So it was successfully done. And as our recommendation part, based on the research presented in this paper, it is highly recommended to proceed with the implementation of the proposed hybrid system for Port Hope Simpson, Labrador. The integration of solar panels and wind turbines alongside the existing diesel generator setup offers significant advantages, including improved energy reliability, reduced operational costs, and the reduced environmental impact. Thank you for listening. I really appreciate your attention, and any questions, please ask. Thank you.